this video, we are starting part 2 of chapter 12, and we're going to be covering objective 5. And so in part 2, it's going to be mostly all about the action potential. But we do need to do a little bit of background kind of setup for the action potential. And so we're going to start by just looking at a stimulus or stimuli. And so these are going to be the incoming signals that are coming in. The stimuli is going to be coming from like your sensory receptors. You know, it could be you're seeing something, you're smelling something, you're tasting something, you're feeling something. And so these incoming signals are going to come into the cell body via the dendrites. And so we know that these stimuli can vary. They aren't all created equal. You can have weak stimuli like dim light or quiet noises, or maybe you eat a small amount of dessert. Or we could have strong stimuli like bright lights, loud noises, you eat a whole cake. All of those things are going to vary in their strength. And so what that does is that creates these graded potentials. And so graded potentials, now remember that membrane potential is that charge difference across the membrane. So a graded potential, there's going to be changes that are made to that membrane potential, but the changes vary. They're not all the same. And so depending on the strength of the stimuli, we're going to have like weak graded potentials and strong graded potentials. And so depending on the strength of the stimulus, different things are going to happen. So if the stimulus is strong, it will create the action potential, which is the movement of that electrical impulse down the axon. But if it's weak, it's not going to actually result in an action potential, because it's going to die out over the course of moving along that cell. And it's not going to actually trigger that electrical message. And so, you know, what determines if it will or will not happen? Well, we have threshold, which is the minimum membrane potential that has to be achieved in order to actually generate that action potential. So the stimulus has got to be strong enough to change that membrane potential to about negative 55 millivolts. So remember, at rest we were starting at negative 70. So the stimulus has to be enough to change it to about negative 55. Now if the stimulus does lead to threshold or meet threshold, then it is going to trigger an action potential. And it is all or nothing. If the threshold is met, the action potential is going to occur and it's going to go all the way down the axon. But if the threshold is not met, no action potential is going to occur. And so you do have some handouts. There's actually lots of handouts in your packet. One of them is looking at these graded potentials. So just to kind of give you an example, if it's a weak signal when it's coming in, as that stimulus is traveling, it's kind of getting weaker and weaker and weaker. And by the time it gets to this trigger zone, this is the axon hillock, if it is not strong enough to meet threshold, then no action potential is going to happen. Whereas if you have a stronger stimulus, even though it is kind of, you know, weakening as it goes, by the time it gets here, it's strong enough to reach that threshold and that action potential is going to happen. And so these graded potentials, or these various changes in the membrane potential, there's going to be some specific characteristics that we're going to look at. Number one, they are localized. And so they're going to be specific changes in that area of the cell membrane. And so as they're traveling into that cell, they are getting weaker. So the farther they get from the source, wherever that stimulus occurred, they're kind of getting weaker and weaker. And so the stronger they are, the farther they're going to travel. And that's why your stronger stimuli can result in an action potential, whereas your weaker stimuli may not. Another important characteristic is that they can be added together, and we call this summation. So if you have multiple of these graded potentials, individually they may not be strong enough to create an action potential, but they can add together, and together they may be large enough to generate that action potential. And then a third characteristic is that there are different types of graded potentials. There are those that are excitatory, which are going to possibly excite the cell enough to lead to an action potential, or they could be an inhibitory type of potential. And so here we have excitatory postsynaptic potentials and inhibitory postsynaptic potentials. And so if it's excitatory, they're possibly going to create an action potential. But if it's inhibitory, they're actually preventing an action potential. And so they can have the opposite effect, and therefore the action potential will not happen. So in talking about stimuli, and we've already talked about these graded potentials, that there's different strengths. The strength of the stimulus is also going to affect the number of action potentials. So the stimulus strength is directly related to the frequency or the number of action potentials produced. Now, in order to create any type of action potential, it does have to be what's called a threshold stimulus. It has to be enough to meet that minimum level to generate the action potential. But the stronger they are, the more action potentials they will be produced. So over here, if you take a look at the diagram, and you actually have a copy of this in your packet. So here's my stimulus, okay? Now here's threshold. This is that negative 55 here. And so it doesn't quite reach threshold. And so notice that up here, there's no action potential, okay? So if it doesn't meet threshold, no action potential at all. Here we have a stronger stimulus. It does meet threshold, and this one generated a total of 3 action potentials. So you can see that each peak represents an action potential. Here's an even stronger stimulus. It does meet threshold and it goes over, and so we get more action potentials from that stronger stimulus. So here's another just example. It's kind of hard to look at all 3 at once, but over here we have a subthreshold stimulus. Doesn't quite meet that minimum level, and notice no action potential occurs here. Here we have a weak stimulus. It does meet threshold, but we only get 1 action potential out of that. And then over here we have a strong stimulus. It does meet threshold, and we get multiple action potentials. All right, so we can kind of classify these different stimuli depending on their strength and how many action potentials they are creating. So we've already kind of talked about subthreshold. Remember that sub means below. So subthreshold are below threshold, which means no action potential. The threshold stimulus it's going to meet that minimum, but it's not going to produce a tremendous amount. Okay, it will produce action potentials though. Now submaximal. So first, let's look at maximal. So your max is going to be your maximum. So that's going to be the maximal number of action potentials that can be produced. And that's going to vary depending on the neuron and the stimulus and all that good stuff. So if it's submaximal, that's going to be between threshold and between maximal. So it's more than just your basic threshold, but it's not as much as your maximum number. Okay, so it's going to be somewhere between the two. Now you could also have a supramaximal. Now super means above, so this means stronger than your maximal stimulus. But once you max out, you max out. So if your maximum was 5 action potentials, even if you have a stronger stimulus, you're still going to meet that 5 max, okay? And so we can see this represented in this graph over here. So subthreshold, no action potential. Threshold, barely meeting the minimum, but you are meeting it, so you do see an action potential. And then sub is going to be between, your submaximal is going to be between your threshold minimum and your maximum. Okay, so notice your maximum here is 5 action potentials. So you can have a submaximal that produces 2, a submaximal that produces 4. You can even have a submaximal anywhere in this range. And then once you hit your max, notice that even with the stronger stimulus, you're still going to stay at that same frequency. So if my max is 5 here, the stronger stimulus is still only going to produce 5 there. All right, so what's going to happen when you get to the end of the axon? So that action potential is going to travel along the axon. It's going to be carried along as an electrical signal. But once we get to the axon terminals, we actually convert that electrical signal into a chemical signal. And so how is that strength carried forward? Well, it's going to be carried forward by chemicals called neurotransmitters. And so if you have a stronger stimulus, you're going to have more action potentials. And so by the time you get to the end, to those axon terminals, a stronger stimulus is going to lead to more of a chemical signal. So more neurotransmitters will be released. So you have a copy of this in your handouts. And so here you have a weak stimulus. Notice that those action potentials are staying the same throughout the axon. Once we get to the end, here's my neurotransmitter release, and you can see how many are released there. Now down here you have a stronger stimulus. You have more action potentials that are created. Okay, notice it is going to be consistent along that axon. But once we get to the axon terminals, we have a greater number of neurotransmitters that are going to be released. All right, we're going to stop there, and we're going to pick up with Objective 6 in the next video. And we're going to talk about resting potential and action potentials.